So this is the Bridgeport milling machine. We have 6 of these, and they're of varying vintages, this one being a newer one, but they all have the same general layout characteristics. They've been this way for 70 or 80 years. So some of the features of this, capacity here is 40, 48 inches, depends on the vintage of the machine. The head can be rotated, tilted, feeds in all directions, manual or power in a lot of directions. And typically we leave the vices on these in the lab, and we have one machine where in the corner we allow the head to be tilted. So try not to move the heads on these. They have been trammed in or zeroed in so they're square, and we can check that. That's one of the first things that I do when I come to the machine after I pick my tools, is to square the head. They do have power feeds on some of them. This one might not be plugged in right now.
Well, your machine's not on.
Well, we'll get this over here. This machine was not cleaned up after the last lab, but I would expect, and the TAs will expect, that the ways are clean and wiped down and there's no chips. You shouldn't really see any chips, especially on the machine surfaces. I'm going to get the square right. One of the quickest ways to check whether the machine is square is just simply with these precision squares. I'm just really checking generally if it's square, but it's a good way to check that. This stop can be moved either by turning it. That's a down stop on the quill. You can just set your setting here, or you can press this button in and move it quickly to a different height. So I typically will drop this down low. This lock holds it. I'll bring it over and I'll look at the air gap right between here. If I can see any gap at all, it's 1/1000th of an inch. Right now, it is not square. So that would take a little bit of work by loosening these bolts in the side here and tilting the head using this screw. That would be forward and back. These are side to side. So I would start by working on that, tilting this. And I can come around to the side here. Look at it in this direction, forward and back, and it's good this direction. So this is a quick way to check square. So this machine is out this direction, and it will then cut or generate a curve when it's cutting. You'll see that in the finish on your part and the quality. Typically I like to run the machine if I'm not drilling with the quill as high up as it'll go. That's the most rigid position for the machine. You're going to pick some material. You're going to have a dead blow hammer, one of the collets that fits. You're going to pick a cutter from our selection and probably use parallels or some kind of spacers to grip it. So get in here, bring the vise tight. These get tight, and tighten that. Alright, so putting the tool in with the R8 holder, These are not interchangeable with the lathes. They're a different taper and require a drawbar. So we have power drawbars on all the machines. That's this button here. You have to hold the green in and press in. Put the cutter in here. Hold it up underneath right here. Keep in mind the cutters are sharp. I press in. It takes about 2 or 3 seconds, and that pulls the collet up, tightens the end mill in there. Alright, so before I make a cut, I'm going to bring the cutter into position. Drop this down. I'm going to give you a couple of examples of cuts. Once again, the RPM can be determined by the speeds and feed charts. So for example, I might bring this over, bring it close. I may even take a piece of paper and hold it under here and bring it up to where it touches. Up underneath here. Until I pinch it a little bit. And if I know this is 3/1000 thick, I can bring the knee up. So I brought it over into position. Let's say I'm going to take 100,000th depth of cut. That's 1 full revolution on this machine. I'm going to lock every direction that I'm not moving the machine. So I've got locks for each direction. This would be in your y-axis. This would lock your x-axis. That's what I'm going to use. Alright, so to turn the machine on, we've got power. And we've got an emergency stop. And it comes up. Came up at 500 RPM. On a cutter this size, if you did the math, 750 would be an okay number in aluminum. It actually probably could go much higher. But I'm going to start with that, see what my finish is on my quality finish. Okay, I'm set to do 100,000th depth of cut. I'm just going to turn this manually. This is about an appropriate feed rate. Gives a good finish. Never reach in here with a rag towards the turning cutter. It'll pull it in. And you can use a chip brush to put cutting oil on there, or sweep chips away, but never use a rag. Chip brush gets caught, just let go of it. So that would be an appropriate feed rate. I'm going to move it over. I'm going to lock this again. So I'm locking the y-axis. Machines are always set up with the z-axis is the spindle, x-axis is your long axis, y-axis is the next shortest axis. So I'm going to take another cut. It's going to throw chips towards me now. And I'm going to move the feed rate up. This is getting to be too fast. And that is definitely too fast. The machine can cut at that rate, but the quality is diminished. But I would not push that any further than what we saw. Depth of cut, it can be as much as 10% of the diameter of the cutter. So if you've got a 1-inch cutter, 100,000th depth of cut is appropriate, or less. The machines can cut heavier and faster, but there is a limit and a range to the type of machine and material. Okay, some other things we can walk around real quick in the shop and finish this. We've got a variety of hand tools, of course. Some of the other power tools that you want to be careful of. The bandsaw being number 1. There's a stick right here to push material through, and I'll get a piece here. A couple important things about the bandsaw. You want there's a lock in the back here. This locks the throat, they call it. So that's your gap here so you can get thicker material through or thinner. You want to bring this down to the minimum clearance you can, maybe an 1/8 inch over that. Then lock that. You always use a pusher stick of some kind, and you can see that as you push through, it can mar these up. So I never use my hands, never use my fingers, never be behind the blade. So one of the more important things about the bandsaw is the 3 teeth in the work rule. You always need more than 3 teeth, 3 teeth or more in the workpiece. So you can see the number of teeth here, like 20 teeth per inch. So it's a finer blade. This material is 1/4 inch. So when you look at it, you can say, I've got more than 3 teeth in the work. That's the rule. The reason is that if you cut something like a sheet metal in this, the teeth will break off and they'll come right back at your face. You'll know it right away. All right, so the bandsaws are set for fairly slow RPM. You can use a cutting wheel on it. And I've got the pusher. My stance is 1 foot forward, 1 foot back. Don't lean in like this. You want to be ready in case something cuts or breaks and you don't fall into the machine. So I'm just going to start cutting. My hands are here. And I don't push real hard. Wait till the machine stops before you reach in and clear it. Parts might be a little bit hot, but that's the proper way to use the bandsaw. Now I could hear a skip, a jump, and somewhere on the blade it's missing some teeth. Drill press, we've got a couple of vices here and clamps, so use the vices. This machine can spin and grab, and when you drill through a part, make sure you're not drilling into the table, but use the vices or clamps to hold pieces, put a block of wood under it, something like that. We've got a good selection of drills too. You probably won't use much more in the hydraulic presses. One of the most important areas is the grinding room, which is covered in welding. So make sure you do not grind on aluminum. That's the most important thing. Use the belt sanders for aluminum, or the wheels that are designed for aluminum. And not brass as well. No soft, non-ferrous materials on the grinding wheels. Just use sanders.
That bandsaw?
Okay, we'll go over this bandsaw. Always ask before you use any stock. This power bandsaw, same rule applies, 3 teeth in the work. So this is a fairly coarse blade. I wouldn't cut anything under a 1/2 inch on this. You can use a hacksaw or one of the abrasive saws in welding or something. But the bandsaw, you can lift it up here. And it is feeding down. Right here is the hold. So to the right holds it in position. It's got a hydraulic on it. And I'm going to load the part. So I'd load the piece that I want to cut. Measure how far out I want to go. In this case, not much. I can move this jaw to where it's tight. And then just tighten this, good and tight. I've measured it, let's say with my tape, and we're ready to cut. Power starts right here. safety was on. There's your safety stop. So safety, power's on. Let's wait till the coolant comes on. Coolant was off as well. So coolant on right here when the bandsaw is on. So we've got coolant. I'm going to release the hole, and I can control that down feed right here, more or less. And that's about the appropriate feed rate for this saw. The machine will turn off automatically when it reaches a stop on the end. Just let the part cut. Supported on either end with a stand if it's going to fall, if it's a longer part. I'm just cutting a small piece off right now as a demonstration. If you have any trouble with the coolant not coming on, just see the TA. So, in summary, if you have any questions for any of the about any of the machines, go see the TA who's in charge and ask. Just ask. There's no dumb questions. So, if you haven't been on these machines before and you want to operate them safely, just ask the TAs or lab assistants.